Hello girls and boys, welcome back from the school holidays. We probably didn't go anywhere and do much, but hopefully it was a break anyhow. And what's really good is next week I'll be seeing a lot of you back at school, so I can't wait. So thank you so much for all of you that sent in your last week's or last term's assignment, and they're still coming in. I'm still pleased to see them, so if you haven't quite finished that experiment, get it into me still, because I want to mark your name off and I just want to be pleased that you've had a go. I just want to also congratulate all the students that became my science stars for the week, but I have to mention Annabelle Fisk. Annabelle did an amazing job of her assignment in terms of her videoing. I think she really does want to take over my job. She did it so well. So well done, Annabelle, because I've made that a new category, a super science superstar. So that was really good to see. Last lesson, we conducted a science experiment, and you all did the same thing at home, where we had to see if we could stop an ice cube from melting too quickly. And I had some wonderful results from all the students with that. But the important thing I really wanted to get across to you boys and girls is we always measure how everything goes against what we call the control. Now the control is that we had an ice cube in a container with nothing wrapped around it. So therefore all the other things must be identical except for what we're looking at, which was what the insulated material, which one was the best insulator. So we needed the same container or close enough to it, and we needed the ice to be the same size. Otherwise you can't really compare. So with my case, I looked at the control against the foil. I had some bubble wrap and I also had some wool. And we all found out from my one, the foil melted, well, I wasn't sure of the exact time. It could have even been a bit quicker than the control, but I looked at the control and when it melted, I checked this one thinking it was going to last longer, but it had already melted. And it was really interesting to see the results of all the other students. Probably about 7 out of 10, the foil ones definitely melted earlier, and a couple they were about the same time, and there was the odd one that was a bit longer, so that was interesting to note too. However, in most cases the foil sped the process up, which is really interesting because often we use foil inside those lunch boxes and lunch cases, but then there's other things there as well, so that probably makes a difference. It was really interesting to see what some of the other students used in terms of materials to wrap the ice in. Some students, a couple of students put rocks completely around the ice. They showed me pictures of them. Oh wow, that's a good idea. And there was another one that had it in salt, and that melted it really quickly. A lot of people use different types of materials. Had a couple of socks there. Others lots of cloths, and some of those cloths and tea towels lasted a long time. But it's interesting, isn't it, boys and girls, because we put our jumpers on in winter to keep us warm, but maybe it's not the jumper that's keeping our body heat in. Because also when you wrap the ice in the wool, it kept the ice colder for longer. So perhaps how we look at things, it's adding a layer to what we are wearing, but perhaps it's just because it's keeping our body temperature warm, and that's why it keeps the heat in. It's a good insulator. The last few weeks, boys and girls, we've been talking about changing to states of matter. And by that I mean when a liquid changes to a gas, or perhaps the liquid changes to a solid changes to a liquid, or a liquid once again turns into a gas again. So each time this changes, it's a change to what's happening to the state of the matter, but the actual item is still the same. Water is water, whether it's in a liquid state, a gas state, or a frozen state, it is still water. Now everything, boys and girls, has a different temperature to when it changes its state. So for example, the water that we've been mainly looking at, it becomes frozen when it's 0 degrees, and it turns into a gas when it's boiling and it's reached 100 degrees. So 100 degrees, when something's really boiling a lot, you've probably noticed yourself that steam comes off, and that's when the water's turned into a gas. But different things have got different temperatures when they change. But water is a very interesting one, and you can see the change of state occurring all the time, particularly in winter. When it gets really cold this winter and go outside in the morning, have a look around at the grass. Have a look at if your car's been outside overnight, have a look at the windshield. Because during the night, the air temperature drops, so the water vapor that's in the air can turn into a liquid, And if it gets below 0 that night, it can turn into ice. And that ice we often see is called frost. And that frost is often on the grass, or sometimes it's on the windscreen of the car as well. And it's literally frozen water. So that's come from the atmosphere, turned into a liquid, and then it's gone into a state of ice. Now, today it's been raining actually, and I just got a couple of blades of grass and I put them in the freezer because they had some tiny droplets of water on it. And I wanted to see what it looks like when they do that. So I'm just going to get one of those blades of grass and show you what it looks like. So if we can just get in there nice and close. You can just see there the little tiny drop. They were tiny droplets of water, boys and girls, and right now they are actually frozen. But if I touch them, they will turn quickly into water because they're that tiny. So you can imagine sometimes in the morning the grass all looks white because all those little tiny droplets have turned into ice. And ice, as you know, goes to that whitey type of colour when it's water is frozen. So it was really interesting just seeing those little droplets getting frozen after being in the freezer for a short time. So water freezes at 0 degrees, but other products don't do that. Now I've put this bottle of Icicle in the fridge. Miss Porteous gave it to me actually because I couldn't get any because of all the coronavirus and people buying it to wipe their benches down. But I've got this Icicle and I've had it in the freezer for over a week at minus 18 degrees. So I want to show you this now. It's been in the freezer. However, you can hear it, it's still liquid, and I'm just going to pour a little bit here. And as you can see, boys and girls, it is still a liquid. So even though it's been in the freezer, it does not freeze until the temperature drops to minus 117 degrees. So minus 18 degrees, my freezer, no way was that going to freeze. Water is only 0 degrees. However, look at the spoon. When you have a cup of coffee, your spoon doesn't melt. And it's quite warm in that cup of coffee or that cup of tea. Do you know the temperature to change the state of metal is 1530 degrees? That is pretty hot. So the temperature to change metal from a solid to a liquid, and you can do it, well, we can't do it in our homes, you need a temperature of 1530 degrees. So that's its melting point, you might call it, from changing it from a solid to a liquid. So it's very, very different, obviously, to ice. Can you see why, boys and girls, that we use different materials to do different jobs? So, because we wouldn't want our spoon to melt. Now, one of the things, I just put on a piece of toast because I was feeling a little touch hungry before. So it's just popped out of the toaster. Not a bad colour. I'm going to put some butter on it. Well, in this case, margarine, very similar to butter. You know, I love better than putting a bit of butter on warm toast. Do you know Miss Cameron hates hot toast and putting butter on it? She puts her bread in the toaster in the staff room and then she waits till it's cold, maybe an hour later, and then she likes to put her butter on because she hates the taste of melted butter. So as you can see, boys and girls, you can't even see the butter anymore because it is melted by the warmth of the toast. This week, boys and girls, I want you to look around and see what things melt at what different types of temperature, what makes them melt. This butter melted on the warm toast. Yet if I had this margarine just sitting here all day, it wouldn't melt, unless it was a really, really hot day. However, ice, for example, I'm going to get a piece of ice. I'm going to put it in that water. Now that water is room temperature. It's been sitting there a little while. So what you're going to find is that water is going to melt that ice. I'm not sure how long it will take, but it will obviously make the water a little bit cooler actually. So this week, boys and girls, I want you to look around and observe what's happening in your household and see what happens when you mix certain things together, or when they're put in on the stove maybe, or I don't know, just taken out of the fridge maybe. What's the reason that they melted? The butter melted when it hit the warm toast. The ice cube, oh look, it's getting pretty tiny right now. It's melting from just being in the water. I want you to think about what you can do that's going to make something melt and the reason why. So we're looking at why it's melted in those temperatures. There's a sheet that I want you to fill out that will be in your Google Docs. I want you to write down what melted and the reason why it melted. What caused it to melt? Okay, here it is. The butter melted when I spread it on the warm toast, and the ice melted when it was placed in the water, which was at room temperature. So basically I want you to see, boys and girls, that different materials melt at different temperatures. They've got different melting temperatures. And then I want you to record that information and send it back to me. Well, I hope you have a great week, and hopefully next week I'll be seeing a lot of you at school on different days. So good luck and all the best till next week. See you later.